Hello friends, welcome to the next stage of our expanded visualization and realization of what's happening in this universe, in this existence. What I'm about to show you comes just from observing, looking through telescopes at stars, mapping their positions, and identifying their distances and location, and then making a map of where they are and seeing what shape they end up making. This is introducing the concept of what's called a galaxy. And your assignment is to draw or write something that reflects on how this makes you feel, as well as answer the specific questions that I outline in the assignment. There will be a Google Docs in addition to this that you will open up and you will write in, but please to also write a piece of poetry or draw something about how this makes you feel. I'll remind you to do that in the Google Docs. The point is, as you go through this, notice what this makes you feel and what it inspires within you. You ready? So we begin with the solar system. Really, we begin with the sun. There's our sun. So the sun is a gigantic ball of plasma held together by gravity. As we zoom out, we go to the planets. They're quite far apart. Mercury, Venus, Earth, and Mars are the inner planets, the rocky ones. You might notice Jupiter, Saturn, Uranus, and Neptune have much bigger orbits. This is our solar system. It takes light, I think it's something like 8 hours to go from one end to the other. You guys are going to calculate that soon, so don't trust me on that. But it's many hours. Many hours light takes to travel. You can imagine your finger taking many hours to go from one side to the other. Maybe you can do that right now. Imagine your finger taking 8 hours to go. I think it's 8 hours to the middle. But again, we're going to calculate that together. What happens if we go further? What's out there? A lot of rocks, the Kuiper Belt. Pluto is just beyond Neptune. Now we're in something called the Kuiper Belt, where there's just icy rocks, little planets, dwarf planets. A lot of space. Comets are out here. This is where the comets go after they orbit the sun. They come from out here. Look at what happens if we continue to zoom out. 1 light year away. Now light took a year to go from there to there. The Oort cloud, everybody say Oort cloud. Oort cloud. It's a Dutch astronomer named Jan Oort who theorized, see those little dots? That's where the comets come from. Comets start there. They actually take 1 billion years to go. Gravity pointing inward. You can imagine gravity lines here all pointing in toward the sun. You can still see the sun there. Right? It's just this little tiny dot. All the gravity lines point in, and it's pulling those comets in, but they take 1 billion years to go in, and they don't actually crash into the sun because they sometimes come in at angles because you imagine them moving sideways. They actually loop around and they come back. Oh, by the way, write down questions you have. Write down questions you have. Come up with as many questions as you can. So many good questions that this inspires pertaining to what I'm talking about right now. And then zooming out, we get to the nearest stars. There we are. The closest star is Alpha Centauri. It's actually technically Proxima Centauri, Proxima meaning closest. The Alpha Centauri system You can see right here. There's Proxima Centauri right there, the closest star to the sun. You might notice we can, I think, turn this around in 3 dimensions. You'll notice as we turn this around in 3 dimensions, we see there's a 3-dimensional matrix of stars. Proxima Centauri is actually in the southern hemisphere. You can only see it from Australia, Argentina, and the South Pole. South Africa, of course, New Zealand, anything in the southern hemisphere. You can't see it from New York. Alpha Centauri, there's Alpha Centauri A, Alpha Centauri B, and Proxima Centauri is actually 3 stars that orbit each other. You can't zoom in on them right now. This computer program doesn't allow us to do that. This is a simulation, of course. But notice what it's doing. It's mapping where these stars are. These are stars. Barnard star is the second closest star. Altair is one of the brightest stars in the night sky. You might see it as you fall asleep, looking out your window some nights. I think it comes out in summertime. One of my favorite stars. Sirius is the brightest star in the sky because it's bright and it's close. Let's keep going. So as we go out, we start to see something profound. And this is what I'm hoping to integrate today. First of all, the distances between things. The distance to the nearest star is 4¼ light years away. So it takes light 4¼ years to go there. And of course, that's the closest star. So you see Vega is there. Vega is a fun star. Pollux, Aldebaran, all these stars. There's so many. By the way, what I believe this plane is the plane of the solar system. So it shows the north and south pole, what can be seen by the north, what can be seen by the south, and of course, if you're on the equator, you can see everything. Not everything, sorry. If something's on the equator here, a star, you can see it from all sides. The opposite way around. So Polaris is one of these North Pole stars here. I think it's actually pretty far away. It's a big star far away. Notice what happens as we zoom out. Something remarkable happens. We start to see what takes shape. Hundreds of millions that eventually grows into billions of dots. That there's actually 100 billion stars, not in the universe, there's way more than that in the universe, but there's 100 billion stars in what we call the galaxy. A galaxy is a collection of stars. And if we zoom all the way out, and we map all the stars that we can see, we realize that we're in this disc-shaped matrix. Matrix meaning a collection, meaning you can imagine lines drawing everything to everything else. A disc-shaped collection of stars called a galaxy. And we call this galaxy the Milky Way galaxy. Now I acknowledge that this is a little choppy. I hope it's not too choppy. I will, after this assignment, post this to the webpage, to the Glassroom site, so you can go to this webpage, but I don't want anybody to play with this yet until they see this video. That the zoom out really shows the details perfectly. That we live in a disc-shaped matrix of stars called a galaxy. I'm rotating it right now. And we are just one star in the middle, about halfway out from the center. And then we can zoom all the way back in. You guys can play with the zoom when you do that. You can click on different stars. I wonder if this will actually zoom us all the way back in. But there's actually 100 billion stars in the galaxy. And our sun is just one. about halfway out from the center of the galaxy. And we're going to see there's actually 100 billion at least galaxies in the universe. We're just one galaxy. I'll show you what those look like and the shape that they make, how they interact with each other later. But for now, just understanding the size of the solar system, all this space, and then the closest star, and then the galaxy. Write down your questions. Please answer the questions that I provide for you. And please draw or write something about how this little journey makes you feel. And I actually just realized right now I will post the link to this because I realize it probably is a little choppy and you guys are going to want to play with this on your own. Thank you guys so much. I see that it's not actually zooming in on my computer. I kind of want to wait for it to. As we do, you can feel this existence set up in this way that everything interacts with everything else and has this exact pattern. Maybe you can feel the space in the room, feel the space within yourself, feel yourself as a galaxy made of so many different pieces, yet there's so much space. And that the space actually allows for motion and allows for interaction and also for transformation. Feel this space. You can meditate on that space. What it feels like to be a galaxy. And you can feel the space in your room, feel the space around the earth. And then come back to the self, space within yourself. Much love to all of you. I'll see you soon.